the same repository that holded the fungible token code, we also see the non-fungible token code. So this is just a standard implementation, but there is an NFT standard described just like for jetons. So here you can find all the metadata examples. Again, this is in accordance with the standard of metadata that we reviewed in the previous lessons. And then you can also have all the specifications on the transfer of the ITEAM smart contract. And it's important to know that we have two types of contracts here as well. We have the collection contract and we have NFT ITEAM smart contract. So the collection contract is deploying the NFT ITEAM smart contract. And as a good example here is shown that if you want to release a collection that contains of 10,000 ITEAMs, you will deploy 10,001 smart contracts. You will deploy it by yourself. And then inside of the ITEAM smart contract, there will be changing owners. So the owner can be changed. Also, the owner of the collection can be changed. But you need to understand this logic that first contract we're going to review is going to be collection. And then we are going to review the NFT ITEAM smart contract. Again, this is not just one contract. This is a system of smart contracts. So let me proceed to the code of NFT collection. So NFT collection smart contract, and just like any other contract, it starts with the encapsulated logic of reading the storage. So here in the storage, we have owner address, we have next ITEAM index, we have content. Again, this content is a cell, and it is made in accordance with the metadata standard that is also available in the same standard repository that we reviewed. And then we have NFT ITEAM code, and we have a cell with royalty params. We're going to learn more about those soon. Just like we have load data, we also have save data, so we rewrite the cell of the local storage. In the previous example with jetons, we actually saw that this calculate state init functions and calculate NFT ITEAM address, they were encapsulated in different file, but here we have them in this standard implementation, we have them in the same file. This is done because we don't really use these functions in NFT ITEAM contract. So this is why we don't have to keep it in a separate file. And in jetons, as you remember, we were using these functions both from the minter contract and from the wallet contract. So here we have them all in one file. So we have a function calculate state init. You don't need any more explanations on that because you went through the very complex one in the jetons. So let's collapse it. Now let's calculate NFT ITEAM address. Again, you don't need any explanations here because you already went through this. Let's collapse it. Let's also collapse the load data and save data. And here we see a few functions like deploy NFT ITEAM and send royalty params. This is all done in accordance with the requirements of the standard. So most of these things, the implementation can vary, but the interface, like what is handled, what must be handled, it cannot vary depending on your project, because you will have to comply with the standard. So your contracts would be considered actual NFT contracts. So we receive internal message, and we see here that we don't want to work with empty body message. So we check if it's empty. Then we check the flags. We ignore the bounce messages. We get the sender. Now we start reading the in-message body, operation code, query ID, and then we read everything from the local storage. So if operation code is get royalty params, then we do the send royalty params. So as you see, we read royalty params from the local storage, and we are passing royalty params begin parse. So we are passing a slice, because royalty params is a cell, and we are passing a slice that could be immediately read into or written into the message that we're going to send. So let's see how the send royalty params is implemented. So we get the to address, we get the query ID, and the data, this slice, it is the royalty params. So we don't want this message to be able to bounce. So that's why we change the flag shortcut here. We send it to the to address, This is familiar to you as well. We put the operation code, we put the query ID, and of course we put these royalty params. It's that simple. You already know how this works. So for the royalty params, we don't even check who's asking for it. What do we see next? We see this operation code. So it means that we want to deploy the new NFT. It can be done only by owner. The important thing here is the index. So you actually keep track of what is the current index of your collection. So for example, here, it has to be the item index that you want to deploy. It has to be lower than the next item index that is stored in our database. And if they're equal, then we will actually increase the next item index and put it into the storage again. So our index would increase. So you would either deploy the earlier index NFTs, or you would deploy the current one, and then you would increase the next item index. And of course, here you're running the deploy NFT item. So have a look how this function is implemented. Deploy NFT item is going to actually deploy a contract. So this is why we are calculating the state init here. We are calculating the address along with state init, and we're sending a message with a certain amount that we also put here. Let's see how we get this amount when we do deploy. So in message body, according to the standard, you are going to see what is the amount of coins that you want to pass there, because here we're setting this as the amount. Yes, here we're setting this as an amount. So we are composing this message with state init, with NFT content, and we are sending and deploying this contract. We are going to see what is the local storage schema once we are going to review the NFT item contract in the next lesson. So deploy NFT item is quite simple. It is much simpler than we did it with jetons, but it works in a similar way, right? So there's another operation code that we want to figure out, and there's even two, but change owner, this is just a standard one. It's very simple for you to understand, so I'm not going to dig deep into this one. But it's important that batch deploy of NFTs, it's a bit more complex, right? So for the batch deploy, you would actually bring a cell, like you would put the cell inside of the in-message body, and this cell would have a dictionary. So you would actually run through all the dictionary that you read here, and you would deploy NFT item step by step. So you want to make sure that your counter never goes higher than 250, because this is the maximum amount of contracts that you could deploy from as NFT items from here. And also you want to make sure that you keep track of the next item index and how it is getting increased again and again in the local storage. And of course, you run the deploy NFT item function on every deploy. This contract is much simpler than we've done with the jetons, but again, this is important for you to see that everything is a contract in Ton. And very simple logic could create a complex system of contracts. So for example, we have in jetons, we had the minter, the wallets are deploying other wallets. And here we have the collection, which is deploying items that are also the contracts. So in next lesson, we're going to review the NFT item contract, and we're going to see how it actually gets initialized with this initial state that we give to it. And it's going to be more than just one contract, because items could have different types of contracts, and we're going to talk about this in the next lesson. So see you very soon.